right. So thanks everybody for dialing in. I'm going to talk about really why companies choose Onshape and some of the unique characteristics of it. And mostly we're going to be revolving around today working with third-party or outside data and how Onshape works with that, how we bring it in and use it. So first of all, some of the differences. First of all, there's no downloads, right? Eric said that we're in the cloud. That means there's nothing to install. There's no service packs, nothing like that. All you need is an email and web access to the internet, and you have Onshape. There are no version conflicts or file incompatibilities because everybody points to the same Onshape instance. Everybody's always on the same version. And that version gets updated about every 3 weeks. And you'll get a little notice in the upper right-hand corner saying there's new capabilities added to Onshape. You can click on that and see the movies representing the different capabilities that were added in that 3-week period, and then you can start working with it right away. There's no crashes or data loss. And crashes, yeah, I'll say, software crashes, but you would never know it. Onshape runs on a server, right, in Amazon Web Services, and for some reason, if that server ever went down, it would just roll over to another server. There's multiple servers that are running at the same time. And Onshape saves everything. There is no file button. There's no save button in Onshape. Every single thing you do is saved. So therefore, you never lose any data. There are no files to get corrupted because there are no files. Kind of a different concept. We're used to using CAD systems that create, part files and assembly files and drawing files and lots of files. But Onshape, you just work on the data itself. It's a database. It's like working in Google Docs, and everybody works on the same information at the same time. There are no license keys or anything like that to manage. Like I mentioned before, the only way or the only thing you have to do to get on Onshape or get at Onshape is an email access. And there's really no PDM required because PDM is built into Onshape. So there's where used capabilities, there's searching by attributes of parts or drawings or assemblies. So the same capabilities and also workflows, right? Release management and things like that, all built into Onshape. There's no emailing of files. You can, but what you'll see is that's kind of crude. The thing is that once you do email, let's say you're emailing a PDF to a customer or something like that, once that email is sent, you have no control over it. What people do with it after that, any of those. So Onshape allows people to share the information. You can just send them a link and they can see the parts, assemblies, drawings that are being worked on. You can give them as much control or as little control as far as viewing goes. So maybe all they can do is just look at it. They can't make a copy of it or anything like that. You have those type of capabilities. And as soon as you don't want them to have access anymore, you just hit the little X next to their name and they no longer have access. So your IP doesn't go wandering off somewhere. So that's what I meant by no IP security issues. So the question always comes up, everyone we talk to here at EAC, when we talk about Onshape, we're talking to somebody who already has a CAD system, right? So they'll have SolidWorks or they might have Inventor or a variety of other systems that are out there. And Onshape needs to be compatible with being able to work with that type of data. So it's very good at doing that because it kind of came around after all those systems already existed. So they didn't have to, change the way that it was written in order to make it work with those systems. So talking a little bit about SolidWorks, they've been around for more than 25 years. Lots of companies use them, and each company has lots and lots of files that they've created. So the question is, what do we do if we wanted to move to Onshape? You can do it. We kind of recommend that you kind of ease your way into it. There is certainly services that we can provide and get you that would take everything out of your, let's say SolidWorks EPDM system and put it into Onshape. But most people, the huge majority, don't do that kind of a flipping of the switch, right? They kind of slowly migrate their projects into Onshape. They can keep the existing CAD system around for archive data and then to pull information in as you need it. So you only need to bring in the information that you need. Certainly standard parts and parts that are purchased, you would bring those into Onshape because those tend not to change. We can use them kind of as they are. You can also make use of Google Drive and Dropbox if we wanted to send information to there, and then Onshape, easily connects with that and can pull that information down. So when we start to import data, and we'll use SOLIDWORKS in this particular example, we import the geometry, right? So we import parts and assemblies. And that can be any version of SOLIDWORKS 1999 or newer. Features aren't imported, so it doesn't do a feature for feature translation, and it just brings the bodies across. So kind of non-intelligent information. By non-intelligent, I just mean it's not feature-based, but Onshape has tools to recognize features and allow you to manipulate those in a parametric fashion. We also don't bring across any mates. All the parts in an assembly are brought in their correct positions, but they aren't mated together. And we'll go through some examples. We can kind of see how that works. And configurations aren't imported from SOLIDWORKS. Although if you have a table of configurations, you can export that out and kind of manually build those configurations into Onshape. It's a lot of work, but it can be done. Drawings are not imported, so you would use DXF or your task scheduler to export out those kind of more neutral type formats to bring into Onshape. And these aren't unique to SOLIDWORKS. This is the same for any CAD system that Onshape deals with. So one of the things I want to talk about is if we were working with SOLIDWORKS and we wanted to grab an assembly and bring it into Onshape, we can use something called pack and go. But what it does is it grabs the right versions of the right parts, zips them up, and then that can be opened in Onshape. Now, the good thing about SOLIDWORKS and Onshape is they're both written on the Parasolids kernel, right? So Parasolids holds the information the same way, it deals with information of the two products the same way. So it's a very good, clean transfer of information between those two packages. So let's kind of look at how this happens. So I have Onshape here, and what we're going to do, let's start by creating a part from scratch. So I'm going to say create a new document. And we'll just call it like Monday, since today is Monday. And so what Onshape does is it goes in and it will create an empty document. And this has a PartStudio tab in it. So PartStudios are where we create the geometry. So here's all the capabilities of Onshape for creating ribs and extrudes and lofts and things like that. Also, the non-parametric editing that I was mentioning before, feature recognition, and then editing of those recognized features. And then there's also sheet metal and some other capabilities as well. And it also will create a tab for assemblies. So after we create some geometry, then we can start putting them together in a logical fashion so that they behave in certain ways if we're making a mechanism or something like that. In this particular case, I want to bring in some information into this empty PartStudio that I have. So I'm just going to come over here and say import. I'm going to import, here's a hydraulic pump, and again, it's from Pack and Go, it's zipped up. I'm just going to say, let's open that up. So Onshape gives you two options for bringing in data. I'm going to go through both of those. The first one is if it's a larger assembly and you want to keep the integrity of the way that it was, the sub-assemblies and the layout and all of that the same, you would use this option. The other one is, I'll do this one first. It brings everything into the PartStudio at once and all organized the way that it is. And so that would be for smaller assemblies, or again, maybe for purchased parts or things like that. So I'm going to use that. We also want to use this option right here, which says make sure that the models point up, which is what SOLIDWORKS does. And I'll say OK. So it goes through a process of uploading the information. And then the second step will go through and it will translate that information, bring it into the Onshape environment. So here it says translation complete. So we'll kind of turn off those messages. You notice we see no geometry here. It didn't put the geometry in my PartStudio, the blank one that it had. So I could say, let's get rid of that one. But what it did is it did bring it in here as a PartStudio. So it created its own PartStudio, put the geometry in there. Here's our assembly that we have. And again, that's empty. So it just brings in the PartStudio. I'll turn off our planes here, and we can see that it's brought in the various components, and we can see them listed down here. So one of the things that we want to do when we look at it this way is it's created all this geometry, all the nuts and bolts and all the components in this PartStudio. If we wanted to make an assembly of this, where we have a bill of material and things like that, I could go to Assembly, and I could say, let's insert this information. So I could insert all the individual parts that were in this assembly, or I can insert the whole thing. And it's not really recommended to do this, but what I'm going to do just to save time is I'm going to say, just bring them all in the whole PartStudio and merge that in. So now we have an assembly, you can see from the tab down here, and we can take a look at it. Now, because the assembly and the PartStudio are the same, the PartStudio had the 4 bolts that were brought in. If we look at the bill of material for this, we can go and take a look at it, and here are all the bolts in the back. And you notice that if I pick one bolt, it's down there. If I pick another one, it's right there. So all 4 bolts are independently listed, right? So that's not a good thing. If we don't really care about the bill of material, like I said, it's a purchase part and it's just going to show up as, a hydraulic pump, then that's fine. But the assembly, because it brought in all the parts, even if they were unique, it brought in all the copies of all the parts. We have something like this that we have to deal with. So I'm going to go about changing this a little bit. First of all, I'm just going to say let's get rid of our assembly here. Go back to our PartStudio, and let's say let's make an assembly. And what I'm going to do is start to assemble the parts together in an intelligent fashion. So I'm going to say create an assembly. And again, we have blank here, and I'm going to say, let's start to insert some parts. So instead of inserting all of them, I'm going to insert some unique parts. So, there's a shaft, we've got a couple of front plates, we've got a housing, got another gear over here. And actually, I'm going to bring in these sleeves as well. So I'm bringing them all in, just the ones that I've picked here so far, and put those in. So they've been brought in the right orientation. But the thing is that when it brings it in, they're all kind of independent. I can grab a component here, grab a component there, and they're just not tied together in, using mates or anything like that. So what I want to do is come in here and kind of put things together. The first thing I want to do is, as you could see, I could drag things all over. I'm going to pick, since it sort of revolves around this housing, I'm just going to select on that, and I'm going to say fix it. Right? So by fixing it, I can't drag it around. It's locked in space. So now I want to start working with some of the other parts. So I'm going to hide our housing right now so we can kind of look at some of these other components. So as we saw, I can grab any one of these components and kind of move them around. What I'm going to do is grab, and this will give us an idea and really give you a good idea of how easily it is that we can create assemblies here in Onshape. So I'm going to pick these 3 parts, and I'm just going to say, let's group them together. So by doing that, it's locked them all together. So if I grab one and move it, they all go. I can do the same on the other side. So instead of having to do individual mates between every single part that's out there, what I do is I just grab the parts that would move together, group them together, and then I can move that around. So now we have a start for our assembly. Let's turn our housing back on. And we'll start to think a little bit about working with the gears that we have here. So I'm going to kind of pull these out a little bit. First thing I want to do is assemble kind of the back face on here. So these are the different constraints we have for assemblies. There's just a regular mate, there's a Revolute mate, there's planar. So all these things to help us create mechanisms or just regular assemblies. So I'm just going to say, let's take this guy right here, and let's line that up with this back face right here. So just one single mate puts those together. I don't have to line the holes up here or put in all these other types of mates. So we'll say that's set. The next thing I want to do is maybe bring in and assemble in this gear here. So in this case, I'm going to use a Revolute, right? So allow it to spin. I can come over here and say, let's select that face. And we want to line it up with the face that we see right here. And he's brought in. So it's a Revolute, so I can rotate him around. Yeah. Let's go do the same with the next one. Just going to come over here, same type of approach, right? And do a Revolute. You notice that it places these different mates on different locations. And what I want to do is just say, let's take the center location, which is the center of this face, and line it up with the center of this one. So we can see that they're all lined up. Again, this one can rotate, right? So what I want to do is, because they kind of work together, I can use this gear relation program and just pick on both of those. And so now if I spin one, the other spins. So very easy for me to make mechanisms, just a couple of clicks, and we're in there. The next thing I want to do is put the front face on. So again, we're just going to use a regular mate here. Grab that. Let's put it with this guy. So he's placed. Now we've got our assembly put together. You can see that here. And again, of course, the gears are working on the inside. Everything's locked together as it should be. Now we saw before that we put in the bolts, and there were 4 of them. In this case, what we want to do is just assemble in a single bolt. So I'm going to say, let's insert one of those bolts. And we'll place it maybe right here for now. And we'll say, let's just do a regular fasten mate. I'm just going to say, let's pick center of that. And the center of the hole here. So the bolt is easily placed there. Now I need 4 of those. So I can replicate that. I can say, let's grab this guy, put him in multiple times, and let's look at this face. That should bring him in. I'll bring them in individually. All right, so now they're all placed in there. The important thing though is that if we go over to the bill of material, we can see that we now have a quantity of 4. So this is how we would go about building it up if we're using that first approach that I used, right? Where it brings everybody in, puts it in the same PartStudio, and then we kind of assemble them in so that we have an accurate bill of material. And that is if we did want an accurate representation of the bill of material. So one of the things I'm going to do here is let's go and take a look at the other way of doing things. So I'm going to say, let's get rid of some of the stuff that we've done. Get rid of the PartStudio as well. We'll take this and let's say, let's import him again. And this time we're going to use this option right here, the first one. And again, this keeps the integrity of the assembly. So this would be for a larger assembly if we wanted to do that, or make sure that the BOM is correct. I'm going to say OK. So it brings those in. If we look at the PartStudio, this will be kind of interesting. We take a look at it and it's like, oh, what the heck is this? what it does is it brings in every part the way that it was created at 0, 0. So you can see all these parts were created at the origin, except for this guy. He's probably made in the assembly, so that's why he's over here. But the things is that only the unique parts, you notice there's only a single bolt here. There's only a single sleeve here. So it only brings in the unique parts. And again, we can go and make changes to these parts, but if we go and take a look at the assembly, we look at the assembly that it brought in, we can see that all the parts are in the right position, and going to the bill of material, most importantly, we see that we can have multiple components. So because only the unique components were brought into the PartStudio, and then they were all assembled the way that they should be in the assembly, we have everything created the way that we want. So again, this is a benefit to doing things this way. If this was a much larger assembly that had sub-assemblies and all that, each sub-assembly would get its own tab, and then there'd be a top-level assembly tab that brings all of those in. So that's what I meant by keeping the integrity of the way that the assembly was put together, keeping all the sub-assemblies separate, and then also having that top level that includes everybody. So that's really the preferred method. Certainly for large assemblies, that's probably the best way of doing things. So that's a little bit about importing in and working with Onshape. That assembly that I put together before, there were like 13 different parts, and I assembled them with 7 mates. So as you can see, it's really quick and easy, much better than any CAD system I've come across as far as putting parts together. Just really simple. But let's take a look at something else. I'm going to close this document out. I'm going to call up a step motor. Okay, this was also imported, and it was imported with a couple of different step or files that were brought in. And this was one of the files that we brought in, and then this was the other. And then I made this part, this kind of component that's going to be holding this in place. And so we brought this in, and the thing is sometimes they always do tend to change. So what happens if the imported files that I had change? What happens to this assembly? So I've made a part, I've added some other parts to it. Let's see what happens. So I'm going to go over to our imports, and here's the import for that part. I'm going to say let's update it with the newer version. So I've got a newer version of this, and you can see it's a parasolids file. I'm going to say let's update that. It says, where is that new part? And it's right there. I'm going to say, bring that in. So again, it's translating it, gives us all the information that we need. If we go back to our assembly, we can take a look at it. You'll notice it's a little bit bigger, at least at first look. That's kind of how things have changed. And of course, because I reference the outside edges and things like that, my holder is going to update as well. So one of the things we can look at, and so remember this was imported, the body was, and then we created the other part. But if we take a look at this, and I want to find out really how did it change? So that's one of the nice things about Onshape is that it saves everything that you do. So I'm going to come over here. I'm going to say, let's kind of expand this out. And I'm going to say, here's what we started off with. It looked like this. And I'm going to say, let's keep with the main idea that our final one. And I'm going to say, let's compare these two. So we can compare the before and after. In fact, I'm going to say, let's reverse it so we can kind of see the drag handle going from beginning to end. So this is what it looked like to begin with. So we get a nice representation here of the model. We also see that the imports are changed, right? They're not equal. So that's giving, and if there were other features that I created, it would show me which features in which version are there. But this is the newest version, and this is the previous version. But there's a little drag handle here, and I can drag this across, and we can see how it changes. So it got wider, and it actually got shorter too. So you can see it's got a little bit shorter. So this is the newer version. So I can see exactly, because sometimes it's not as obvious how things change when we bring in a new version. Even if everything updates, is this going to affect another part that this is being assembled to? So this ability to do these compares real quickly, visually, and also graphically, or I should say listing out feature by feature, is really a nice way of keeping us up to date as to the changes that went on by updating an existing imported file. Let's go back to our PowerPoint here, just kind of to summarize things a little bit. Onshape is minimal hardware, right? Anything that can access the internet. It doesn't even have to be a good computer. You don't need a lot of RAM. Your access, 3 megabits per second is really probably the minimum, and that's like a really bad connection, but Onshape would work fine with it. Instant deployment, because it's already deployed, right? It's already on the Amazon Web Services. All we're doing is accessing. Next to nothing as far as IT overhead, right? Because it's all being taken care of by Amazon. All we're doing is accessing it. They're updating it for us whenever there's new versions. And then real-time collaboration. We didn't really do that today, but that's really one of the greatest powers of Onshape, is to have multiple people working on the same data at the same time and being able to see other people's changes right away without having to go and do a refresh or go and check something in or check it out again or any of that. There's no lost or corrupt data because everything is being saved, as we talked about before, and all the servers are backed up, and your models are backed up multiple times as well. And then training and support between Onshape and EAC is second to none. There are great training online tutorials that are there. There is videos that you can watch, and there are also technical papers. And there's a support forum that you can go in, ask a question, and somebody will answer it for you. So to get you up to speed and using Onshape, between EAC and Onshape, we've got you covered.